Episode 4. So, episode 3 trained the brain. Now, episode 4 gives it eyes. And we are taking our baseline logistic regression model, loading a real chase, and making it spit out win probability ball by ball. And then we'll do the spicy part, biggest turning points, explain why probability moved, and run a what if alternative universe. So basically, we are building a Cricbuzz but with math. Now, I'll show you what we are actually building today. So we'll load the model JSON from the episode 3. So this is our baseline logrid.json that we discussed in episode 3. And we will load a mass state ball from episode 2. You can see our mass state ball.csv. So we will be loading this. And we'll pick one match ID and filter innings to. As I discussed in the last episode, we were mostly focused upon innings 2 since we were concerned about the chase. And then we'll predict the win probability for every ball. We'll create an over by over review. We will find the top turning points, the biggest probability swings, and we'll also see what features can be pushed probability up or down, and what if overlay, like how can we analyze that it makes chase easier and reduce wickets and see the net effect as well. And at last we will save everything, the plots plus CSVs plus the summary report. Now I'll go over my code. So I already have this code with me. You guys don't have to worry about the code again. I'll provide the link to my code base in the description, so you can just go through it and it would be much easier for you as well. So as you can see on the top of my file, it's the basic stack again, like pandas for data, numpy for math, matplotlib for plots, JSON because our model lives inside a JSON file, and argparse because I want to run this like a proper tool. Now as I go down, we have our data path, model path. So what exactly is this? So I already discussed this in the last episodes as well. So these are basically my GPS coordinates. So if these paths are wrong, the model won't predict anything and it will just emotionally damage me. Now as I go down, we have our insert dir function. So I have discussed this as well in the last few episodes. So this is our safety net. It creates folder if they don't exist. No deleting, no overwriting drama, just hey folder, exist please. And as we go down, we have our Sigmoid function. So I also discussed this in the last episode. So Sigmoid turns a score into a probability between 0 and 1. And the clip is important because exponential 1000 is basically Python screaming and leaving the chat. Now, as I go down, we have our normalize function. So this is something that was similar to the normalization from the episode 3, and we don't want runs remaining to bully pressure just because it has bigger numbers, so we standardize features. Now as I go down, you also have a load model.json function. So what we are doing is, this function is a bridge between training and production. So episode 3 it saved the model, and episode 4 it would just load it. So here we validate the JSON, and it has all the keys like weight plus bias, which is basically the brain. You also have your feature orders, which is the rules of the universe. Then you also have your mean and standard deviation, which is basically the scaling recipe. And we convert everything into numpy arrays because math works faster and cleaner. Now, if your JSON is missing even one key, this model is not a model, it's just a random list of numbers. So you need to make sure that your JSON file includes every metric. Now, let me go back to my code base. So I'll tell you about this function now. Select match innings 2. So what exactly are we doing here? Now this is important because we are predicting only the second innings, because our label is chase win and we sort by legal balls bold, so the timeline is correct. And if you don't sort, the win probability curve becomes a horror movie. So we need to be careful about this as well. And as we go down, you also have your predict prof function. And as I told you about this in the last previous episode, this is the entire interference pipeline. So it takes the match state features, it normalizes them with episodes 3 mean and standard deviation. Then it also computes the linear score like x dot weights plus bias. And it also runs Sigmoid. And I told you Sigmoid is important because it turns a score into a probability between 0 and 1. So it runs the sigmoid to a win probability, and that's it. This is logistic regression in production form. And yes, this is the exact moment where we turn cricket into probability. So as I go down, you'll see a function that is compute logic and contrib. So what exactly is that? This part is y behind the number, and the model output comes from a logic score. Each feature contributes to the score, and we compute scaled feature plus weight for every feature. So I can literally say RRR pushed probability down by this much and wickets pushed it up by this much. So all of that, it happens using this. And then let me just scroll down. You see an explain row option over here. So here we pick up the top 3 positive and the top 3 negative drivers. So the model basically gives a post-match interview like, yeah, we lost because pressure was too high and wickets were missing. Now I'll just go down. You have your add over column over here and your over level snapshot, right? So what exactly is this? Ball by ball is great, but over by over is cleaner for most viewers. So we create an over number from legal balls and take the last ball of each over as a snapshot. So that is what's happening over here. Now you also have your top swing function over here. So this is my favorite feature in episode 4. We compute how much the probability has changed from one ball to the next, and then we rank the biggest absolute changes. So instead of watching the T20 balls, which is like 120 balls in total, we get the top 10 story changing moments. So basically match highlights but for nerds. Now I'll go down. Now I have also plotted various curves, like I have my plot ball curve, I have my plot over curve, and I have my what if overlay curve below. So what exactly are these curves and what do they tell you about? So first let's discuss the ball by ball plot, which is this. This plot shows a probability curve for every legal ball. So you'll see sudden drops at wickets, you'll see sudden jump at boundaries and slow pressure build up. And then you have your over curve. So this is the same thing but smooth at over endings. So it is basically very easier to read. Now as you go down, you have your overlay, that is what if overlay. So here's the alternative universe simulation. From a chosen ball onward, 1 adjusts the state. So you have runs remaining -10. That means the chase would become easier. And then you have wickets remaining -1. That means the chase would become harder. So after that, I then recompute the RRR and pressure so that the state remains logically consistent. So this is like what if the scoreboard helped you, but your batting order has betrayed you. So that's what exactly it is. At the end, you can also see a right summary function over here. So basically at the end we generate a simple match summary, like you have your start, mid, end probability. This helps when you want quick insights without opening charts. Now since I have already explained you the most important things that were required in the code, now just run the episode 4, and here what I would do is I'm passing the match ID and enabling the what if overload. So what is this going to do is this will generate the plots, a swings.csv, a summary text file, and the full prediction CSV. So I'll just show you the command that you have to type. So this is the command. Now you gotta press enter. So now as you can see, this is the explainability. For each phase of the innings, we are printing the match state. We are also printing the win probability and the top positive plus the negative driver. So the model is basically, it's not just guessing, it's telling you what it cared about. Like, I don't hate you, I hate your required run rate. Now what we are going to do is we'll open the generated file that this command that I typed generated. So what I'm going to do is I'm going to go over to my output over here. I'm going over to my report, and then I'll open my swings.csv. So as you can see, this file is gold. It exactly tells you which balls change the match the most. So look at delta.probs. So you'll see the delta probs over here. Positive means chasing, team's chances improved, and negative means it crashed. So just as a mini lessons, a boundary can jump probability, but a wicket can absolutely nuke it because wickets are basically future scoring capacity. Now, I'll also open my output. So I have my output here. I'll go over to my predictions over here, and I'll open this probs.csv. So this is my file. Now this is the complete ball by ball data set with win probs included. So this is what we will be using later if we want a dashboard, a web app, or a live prediction. So this is it. Now I'll show you the plots that we have generated. Now let me go over to my plot over here. Now you'll see the episode 4. So it generated 3 plots for us. So let me just open the ball curve. So this is my ball by ball win probability curve. This is the raw emotional roller coaster. So probability reacts to events like wickets, boundaries, and pressure. So you can see that over here. Now I'll go over to my over curve. So this is basically the cleaner version, probability at the very end of the every over. And then I also have my overlay plot over here. So this is where it becomes interactive. The dashed curve is our what if universe, same match, same timeline, but different state from ball 85 onwards. So this is literally time travel, but only for cricket. Now episode 4 is done. We have interference, we have our explainability, the turning points, and the simulations. Next episode will make this usable like a real tool, maybe a CLI that takes inputs, or a tiny UI, or a live match predictor pipeline. So if you're still here, you're officially part of the sports analytic cult, and welcome. So I will answer some basic questions that most of these viewers already ask us. So why we clip Sigmoid inputs? So without clipping, extreme logics cause numerical overflow. So the model might output NANs and ruin everything. So clipping, it keeps it stable. And second, I'll also tell you about the difference between probability and certainty. So even a 0.8 probability match can be lost. And it doesn't mean a guaranteed win. It means historically states like this win 80% of the time. And then you have your turning points and the match highlights. So traditional highlights, they show you run. Turning points show informational change, like a wicket at the wrong time can be a bigger than a 4. So thank you so much, guys. That's it for episode 4. So stay tuned for the next episode, and I will see you in the next one.